Hello and welcome back. So here we're looking at finding the nth term of linear sequences. So the objective here is to recognise what a linear sequence is, find the nth term using the pattern rule, and use the nth term to generate terms and solve problems. So a quick definition before we get started. So a linear sequence is a sequence where there is a common difference between the terms. So for example, we have 2, 5, 8, 11, 14, 17. This is a linear sequence because you can see that to get from one term to another, you add 3 each time. Okay, and so because there's a common difference of 3, that's what makes it a linear sequence. This next one here, to get from 3 to 1 and then 1 to -1, -1 to -3, you can see we are subtracting 2 each time. So this is also a linear sequence because to get from one term to another, you minus 2. So there's a constant common difference there. This last one, so we have 4, 8, 12, 16, 20, 24. So you can see this is the 4 times table. So to get from one term to another, you're just adding 4 each time. So again, this is a linear sequence because there is a common difference of +4. So here's an example. So it says find the next 2 terms of the following sequences. So we have this one, so 2, 5, 8, 11, 14, 17. So we can see that to get from one term to another each time, we're just adding 3. So the next term is going to be 17 plus 3. So the next one is 20. And then the next one is going to be 20 plus 3. So that is 23. Okay, so that's the answer to that part. This next one, to get from 3 to 7, 7 to 11, 11 to 15, you can see we're adding 4 each time. So we need to add 4 to get the next term. So 15 plus 4, that's 19. And then add 4 again, we end up with 23. Okay. This next one, so 10, 8, 6, 4, you can see we're minusing 2 each time. So to get to the next term, we need to minus 2 from 4, so that's going to be 2. And then to get the term after that, we're going to minus 2 from 2. So 2 take away 2 is 0. So that's the answer to that one. So this one here, so we have the nth term of a particular sequence is 5n plus 1, generate the first 5 terms. So the nth term is a rule to generate any term in a particular sequence. So if we want the first 5 terms, the first term is when n is 1. So we have n equals 1, we substitute n for 1, so it's going to be 5 times 1 plus 1. So 5 times 1 is 5, and then 5 plus 1 is 6. So the first term of this sequence is 6. The second term is when n is 2. So we're going to replace n with 2, so it's going to be 5 times 2 plus 1. So 5 times 2 is 10, and then plus 1 is 11. The third term, n is 3, so we're going to replace n with 3. So it's going to be 5 times 3 plus 1, which is 16. And then n equals 4, so it's going to be 5 times 4 plus 1. So 5 times 4 is 20, 20 plus 1 is 21. You can kind of see a bit of a pattern emerging with the terms in the sequence. It's kind of alternates between 6, 1, 6, 1. So you can kind of see that the next term, without even working anything out, is going to be 26. So the first 5 terms are 6, 11, 16, 21 and 26. This next part says find the 100th term. So the 100th term is when n is 100. So this time we're going to replace n with 100. So it's going to be 5 times 100 plus 1. So that is 501. This example here, it says the nth term of a particular sequence is 3n minus 4, generate the first 5 terms. So again, we're going to replace n with 1, 2, 3, 4 and 5. Okay, so if we do that, when n is 1, we're going to do 3 times 1 minus 4, which is minus 1. When n is 2, we're going to do 3 times 2 minus 4, which is 2. When n is 3, we're going to do 3 times 3 minus 4, which is 5. When n is 4, we're going to do 3 times 4 minus 4, which is 8. And then when n is 5, it's 3 times 5 minus 4, which is 11. And you can also kind of see that you're adding 3 each time. So that is the first 5 terms of this sequence. The 50th term is when n equals 50. So this time we're going to replace n with 50. So it's 3 times 50 minus 4. So 150 minus 4, that's 146. So the answer to this one is 146. This one here, we're finding the nth term. So find the nth term of the following sequence. So sometimes we're given a sequence and we need to work out what the term-to-term rule is. So we need to work out a rule to generate any term in the sequence. The way we do this is a bit of a method. What we do first is work out what the common difference is. So to get from 2 to 5, you add 3, and then 5 to 8, you add 3, and so on and so forth. You can see you're adding 3 each time. So the sequence is going to be some variation of the 3 times tables. So it's going to be 3n plus or minus something. So to work out what it's been shifted by, to get from the 3 times tables to our sequence, you work out what the 0th term would be. So if the first term is 2 and we're adding 3 each time, the term before the first term would be -1. So I just did 2 take away 3, which is -1. So the 0th term is -1, and that's going to give us the nth term of the sequence. So step 1 is to work out the common difference and then put an n next to it. And then step 2 is to find the 0th term and then complete the answer by putting the two things together. This one here, so to get from one thing to another, we're finding the nth term. You can see we're minusing 3 each time. So it's going to be -3n, and then you'd work out the 0th term, so the term before the first term, to work out what it's been shifted by. So in this case, if you add 3 to 10, you end up with 13. So the nth term of this one is -3n plus 13. So this one here, you can see that to get from one term to another, we're adding 6 each time. So again, it's going to be some variations of the 6 times table. So it's going to be 6n. And then to get the 0th term, you're going to -6 from 25. So you end up with 19. So it's going to be 6n plus 19. This one here, so it tells us the nth term of a sequence is 3n minus 2. Is 40 a term in the sequence? So to do this, what we would do is we'd assume it is a term in the sequence, and we're finding the value of n for which the sequence is equal to 40. So in other words, we need to equate 3n minus 2 to 40. Now if we solve this, we add 2 to both sides, so 3n equals 42, and then solving this, we end up with n equals 14. So the answer to this question is yes, it is, because we've just proven that it's the 14th term in the sequence. So yes, 40 is the 14th term in this particular sequence. The next part, it says the nth term of a sequence is 5n plus 1. Is 97 a term? So again, assuming it is, we want to find the term that 97 belongs to. So we're going to say 5n plus 1 equals 97, and we're going to try and solve this for n. So if we first start by subtracting 1 from both sides, we end up with 5n equals 96, and then dividing both sides by 5, we get 1, so that is 19, remainder 1, so it's 0.2. So it would be the 19.2nd term. Now you can't have a 19.2nd term in a sequence, that doesn't make sense. You can only have integer terms in a sequence. So this is going to be a no. So the answer to this question is no, and the reason for that is because you can't have a 19.2nd term of a sequence. Here's an exam style question. So it says a sequence has nth term of 7n minus 12. Write down the first 4 terms of this sequence. So what we're going to do to find the first 4 terms is we're going to sub in n equals 1, n equals 2, n equals 3, and n equals 4. So n equals 1, so it's going to be 7 times 1 minus 12, which is minus 5. N equals 2, that's going to be 7 times 2 minus 12, which is 2. N equals 3, that's going to be 7 times 3 minus 12, which is 9. And n equals 4, we're going to do 7 times 4 minus 12, so that is, so 28 take away 12, that's 16. So that is that. And then it says, is 50 a term in the sequence? So we're going to assume it is a term in the sequence, and we're going to find the value of n for which 7n minus 12 equals 50. So if we add 12 to both sides, we get 7n equals 62. And you can see that 62 isn't divisible by 7. So n would be 62 over 7, but because that's a decimal, you can't have a decimal term in a sequence. So the answer to this question is no. So here are some quick-fire practice questions where you need to find the nth term of the following sequences. So pause the video and have a go at these, and I'll reveal the answers in a moment. Okay, so here are the answers to these questions. Well done if you had a go at those, and well done if you managed to get them all right. So that's everything for this video on linear sequences. In the next video, I'm going to be walking through how to find the nth term of quadratic sequences. So feel free to have a look at that if you want to learn more about that. But otherwise, I'll see you again in another video. Bye!